Ahead of the Florida Ruminant Nutrition Symposium hosted by the University of Florida, Balchem hosted one of its mini symposium. I'm Andy Vance and welcome to another Symposia Soundbite. Dr. Peter Hansen, one of the professors at U of F, was also one of the presenters at the Balchem Mini Symposium. Dr. Hansen, if you had to recap your talk in 60 seconds or less, how would you describe your presentation?
I would say what happens to you when you are just a few cells in total, when you are early embryo, can have consequences for your existence after you're born. And that's becoming more and more obvious. And I guess the reason I was invited to speak here today, methyl donors, molecules like choline that are showing increasing use as feed additives, are some of those molecules that can program the early embryo to affect its life after birth. So that's kind of some of the research I do and the message that I tried to deliver today.
There's this term I saw in the title of your talk, and one I'm hearing more and more as I spend more time with Balchem at these mini symposia, the term of epigenetics.
That's right.
Can you give a humble ag communicator a quick lesson in what epigenetics means?
Yeah, so genetics is the study of how genes affect your function. And we differ in every aspect of our life because our genes differ a little bit. But what we've learned now is that the way those genes are organized in the nucleus can also affect how those genes function and can be inherited. So you could have a change in the organization of your genetic material that gets passed on to other cells in your body, or maybe even passed on to your offspring. So you've kind of caused a genetic change without actually changing the genes. So it's epigenetic, around genetics.
And so when we tie this into your talk, something like choline in those early days after conception are especially important in the overall life of that offspring.
That's what our data is telling us. And this research is just beginning. We really haven't gotten to the point where we can say, feed this amount of choline and you're going to have this impact on the future milk yield of the offspring. But that's what we're trying to get to. How can we manage the environment of the early pregnant cow so that her offspring, when they're a cow, are more productive?
When you're talking to a room full of nutritionists and trying to give them something they can get their teeth into on this topic, admitting that the research is still far down the pike, what would you say if you were putting yourself in the boots of a nutritionist managing a herd of cows?
I think I would be more aware of the fact that what you're doing to feed the cow to increase her milk yield could also be having some effects on her offspring. And a lot of epigenetics, kind of from the human perspective, focuses on the negative consequences of an adverse environment. But I think actually there might also be some positive effects. So maybe something like choline, which is being fed to increase milk yield or increase milk protein, might have some additional benefits, not for the cow, but for the cow's calf. We still need to work all that out. I mean, we're not there yet, but I think there's great opportunity down the road to kind of shape that productive unit, that cow, when it's still an embryo. And so that's pretty exciting, I think.
Reinvesting your dividends seems like
that's
a pretty good topic and a pretty good concept. I look forward to future discussions. Dr. Peter Hansen of the University of Florida, one of the speakers at Balchem's Mini Symposium ahead of the Florida Ruminant Nutrition Conference. With Feedstuffs, I'm Andy Vance.